Okay, so example 2, still on the third use of dimension. The third use of dimension, that's which will derive an equation between quantities. It is what used to what derive a formula between what quantities as well. Okay, so example 2, it says the frequency f of a vibrating string depends on the length L of the string, the tension T in the string, and the mass per unit length U of the string. Derive an equation between FLT and U. Okay, so now we are coming to solve it. So the frequency F of a vibrating string depends. So the frequency, yes, the frequency of a vibrating string depends. As I said, as soon as we hear depends, you bring this word symbol. Yes. So it depends on length L. So length L, your L depends on length L of the string. The tension T, so T as well. Then mass per unit length U. Yes. So that's the first step. That is the first step. Okay, let's move on. So F L to the power X, T to the power Y, U to the power Z. As I said, I decide to bring A, B, C, or use X, Y, Z. So I'm using X, Y, Z. Okay, let me change the marker. Now, F, because of this symbol, you introduce what is equal to, and we bring K as a constant as well. X. So F equal to K, then L, X, T, Y, U, Z. Okay. After that, we take the dimension of the parameters. Okay. So dimension for the F, that's the frequency, and the dimension of the L, that's the length. Okay. We take the dimension of the T, that is the tension, and you take the dimension of the U here, that is mass per unit length. So power is Z. Yes. Okay, so you take the dimension of the parameters. Okay, so what is the dimension for frequency? We know the frequency equals 1 over period. Yes, so 1 over period. Period is what T. The frequency 1 over period. Right. So taking dimension of it, you get 1 over T. Then it will what T to the power negative 1. How am I getting it? Yes. Supposed to know it. You are not supposed to even work it out here. You're supposed to know it. Okay. So frequency is T to the power negative 1. T to the power negative 1. T to the power negative 1 equal to K. Then the dimension for L. In the question, they said L is the length. So dimension for the length is L. You capital L. And bring the X to the power X. Dimension for the T. The T here in the question, you say T is the tension. And tension is a type of force. Tension is a type of force. And we all know that the dimension for force is MLT neg 2. MLT neg 2. Yes. Yes, MLT neg 2. That's dimension for force. Yes. So, and tension is a type of force. So therefore, the dimension for tension is MLT neg 2. Okay. So then all of them to the power Y. Okay. And U, the U here in the question says is what mass per unit of length. Mass per unit length. So mass per unit length, that's M over L. Yes. So mass per unit length. So we get M over, taking the dimension of it, you get, you can work it somewhere over L. Because of M, L to the power negative 1, right? 1 is here, you don't write it. While it's moving up, you get what? Negative 1. Yes. So mass per unit length. U is mass pennies and m. L equal to m is here. This one is moving up because of the division. You introduce negative, but 1 is here, so it will negative what 1. Okay. So m L to the power negative 1 z. Okay. So we are expanding the bracket. So t to the power negative 1 equal to k as a constant, L to the power x. Then this one will affect the m. So m to the power y, L to the power y, t to the power negative 2y. Then m to the power, this one to when it comes here, this one you affect so m to the power z, L to the power, this one affects this one too, so negative z. You can see? Yes. So this one will affect what is inside the bracket here. So m to the power negative, m to the power y, L to the power y, t to the power negative 2y. This one too will affect all those in the bracket as well. So m to the power z, L to the power negative z, because negative 1 is here. So negative z. Okay, continue. Now m, let's come to m. For the m, we have how many m? We have 2. Yes. This m and this m. So but we write only one m. Okay. So this to the power y. When it comes here to the power z, so plus z. Right? Yes. So we are down the m. Then we will come to the L as well. For the L, how many L do we have? 1, 2, 3. Yes. 1, 2, 3. So the first one is x, then plus y, then minus z. Okay. Then come to t. We only have one t. That's t to the power negative 2y. To the power negative 2y. Yeah, t to the power negative 2y. Yes, so that's what we have. Comparing the powers. So now compare the powers of t. When you come to the left hand side, the power of t is what? Negative 1. Yes, it's negative 1. Okay. So equal to, when you come to the right hand side, the power of t is what? Negative 2y. Negative 2y. Okay, so now negative 1 is equal to negative 2y. Verb goes by negative 2y, right? Because we want to find y. Verb goes by negative 2y. This one cancel this one. And this one, sorry. And the negative will cancel the negative as well, right? So therefore, y is equal to positive half. Positive half. Yes. Y is equal to positive half. Now compare the power of n. Comparing the power of n. When you look at the left hand side, you don't have any m there. Yes. Here you don't have any m there. So at the left hand side, the power of n is equal to 0. When it comes to the right hand side, the power of n, right hand side, the power of n is what? Y plus z. Y plus z. So 0 equal to, but we have z. Z is equal to what? Half. Sorry, we already have y. Now solve for y. Y is equal to half. So therefore, half plus z. Therefore, z is equal to negative half. Well, this one can come here. Yes. So therefore, z is equal to half. Okay. Now comparing the power of L. Yes. Checking at the left hand side, you don't have any L there. So the power of L at the left hand side is 0. Let me take the marker. And the power for the L at the right hand side is x plus y minus z is x plus y minus z. But the left hand side is what? 0, because we don't have any L there. Okay. So 0 equal to x. We have y. We have y is what? Plus half. Y is plus half. And we already have z as well. Yes, we already have z. So minus z. So minus z. Z is negative half. Z is negative half. And we have minus z. So z is negative half. Negative half. Okay. So therefore, 0 equal to, let me change the marker. Z is equal to x plus half, negative 4 plus and a half. 0 is equal to x plus 1. Half plus half is 1. So therefore, x is equal to negative 1. Yes, this one will go here. So that x will go here. So therefore, x is equal to negative 1. Okay. Let's continue. So we have solved for the parameter. So as a matter of that, f is equal to k, then L. Yes. L is x. X is here. X, you got what? Negative 1. X, you got negative 1. Negative 1. Then t, that's y, right? T, that's y. T, y is what? For the y, you got half. For the y, you got positive half. You got positive half. Then comes the u. For the u. For the u, you got, that's z. Z is what? Negative half. Negative half. Yes, negative half. So you write it proper. This is the equation or the formula we have gotten. But you want to write it proper. Yes. So f is equal to, we have k. Because of the L to the power negative 1. L to the power negative 1. Because of the negative, you bring this division and 1, and the L can come down. Right? Yes. Because of the negative, bring the division and the 1 can come down as well. Okay. Then t, because of the half, you put it inside the what? The square roots, as we did the first example. Yes. So because of the half, you put it inside the square roots. T to the power half. So we put the t inside the square roots. Okay. Then u. U2. Let me change the marker. So u to u, because of the half, you put it inside the what? The square root as well. But it's having negative, and because of the negative, you introduce what? Division sign. You introduce what? Division sign, and you put the u inside the square root. Yeah, that's it. So that's the solution. That's the solution. So because of the negative, you bring division and half. When you say half, you put it inside the square roots. Half inside the square roots. And that's 1, 2. As you can see, if you're having 1 over L, it's the same as what? L to the power negative 1. Right? So that's why we are having that one here. And K is what constant there. Right? Yes. So that's the final solution for example number 2. So I will post the next exercise concerning the third use of dimension on the WhatsApp platform so that you can try your hands on and send it to me to mark it for you. Thanks for enjoying today's lesson.